All right, so now I'm going to get into something I'm going to call tricky U. I've used easy U, I've used clever U. This is just a way to help distinguish between the different types. This is going to be called tricky U. So first, it's going to be U substitution. You let U equal more than the inside function. That's not what we've done before. Second, really important, you solve for x, sometimes sort of, before you take the derivative, and then you simplify once you get everything in. Okay, so like looking at this problem right here. Easy U would be let U equal x plus 4. We're not going to do that because that's not going to work. So what we're going to do is we're going to let U, let me get rid of that so you can see, we're going to let U equal all of the square root of x plus 4. This next step is really important. You never want fractional exponents when you're taking the derivative. So I'm going to square both sides before I take the derivative. Then I'm going to even move this 4 over to the other side. Now take the derivative. So the derivative of u squared is 2u du, and the derivative of x is just 1 times dx. Now I'm going to do the substitution. So this is just u. This dx gets replaced with 2u du. And on the denominator, here I have x. So I'm going to take this, and I'm going to solve it for x. So x will be u squared minus 4. So x gets replaced with u squared minus 4. So I'm always going to pull numbers on the outside. So I pulled the 2 on the outside. This u times this u gives me a u squared. And then I've got this u squared minus 4. All right. So I notice I have a polynomial over a polynomial. The degree of the numerator is not smaller than the degree of the denominator. So I need to do long division. All right. Or you can do the trick of subtracting 4 and adding 4. Either way. So let me show you the trick. Remember, if I have u squared over u squared minus 4, u squared minus 4, I could say this is u squared minus 4 plus 4 over u squared minus 4. And then break it up, right, around the addition in the numerator. So I'd get u squared minus 4 over u squared minus 4 plus 4 over u squared minus 4. So this will give me a 1. So that's where this comes from, okay? Or you could do long division. So the integral of 1 is just, with respect to u, is just u, right? So this integral of 2 times the integral of 1 gives me a 2u. Then this guy right here, 4 over u squared minus 4, I need to break up that denominator to u minus 2 times u plus 2. And I'm going to do the partial fractions, which is that a-b thing, right? So I've skipped a bunch of steps here, but it would be u minus 2, u plus 2 equal a over u minus 2, b over u plus 2. Multiply both sides by the denominator. Sorry, got interrupted. So multiply both sides by the denominator. So this side turns out to be 1. This side here turns out to be a times u plus 2. And this is b times u minus 2. And remember, you pick the y's numbers. So you would pick u equal negative 2. And so then you would get negative for b. So negative 1/4 for b. And I'll let you find out that a is positive 1/4. And so that's where these numbers come from. And then you take the antiderivative of those, and that's where this is. Shoo! All right. And where did this, oh, this, I pulled this 4 on the outside, so that's where this 8 comes from. So that's tricky U substitution for this example. So when you do tricky U, you always want to do the simplifying, and you never know what you're going to get out of there. It could be partial fractions.